Welcome back to College Algebra. In this lecture video, we're going to continue with our 7.1. So object number 2, something called the one-to-one function. Okay, so a function f is to be said one-to-one if every pair of distinct elements x1 and x2 in the domain of my function f. Okay, so these two are distinct. Then f of x of 1 cannot equal to f of x of 2. So that means I got two distinct, okay, x value. If I actually plug into my function f, then the y value, the two y value with two different distinct x value should not be the same. That means that for every element of the range of the f, okay, pair with exactly one element of the domain of my function. Okay, so what that means is this. Okay, if I have two distinct x value, okay, so plug into the function, whatever the function is, then the two y value should not be the same. Okay, in that case, we say the function is one-to-one. Now, if we go by what this thing is saying, for the function to be one-to-one, every element of the range of f pair exactly with one element, okay, of the domain of f. So if I have 3, okay, and 4, okay, if my range, every element in the range pair with exactly one element, okay, pair exactly with one element, so that right here is the same thing as what the y value cannot be equal. Now, we mentioned this before. To be a function, the x value cannot be the same. Alright, if I have the same x value, but I have two different y value, then it is not a function. Now, even though this is not a function, if you actually go by what this is saying, every element of the range pair with exactly one element of the domain. So this is actually not a function, but it's a one-to-one function. So that's the different scenarios that we are actually talking about. Okay. So to be a one-to-one function, not a one-to-one function is if you have the same y value but a different x value. That's not, that's what the definition is not saying. Okay, because the definition is saying what is a one-to-one function. So what is not a one-to-one function is where the y values, okay, is the same y value paired with exactly one element. So in other words, to be one-to-one, okay, the y value got to be different. So when the y values are the same, okay, when the y values are the same, then it's not a one-to-one function. So if you actually plot 1, 4 and 2, 4 on the graph, it will actually provide you with a horizontal line. So we use horizontal line to test whether my graph, okay, is one-to-one function or not. Okay, vertical line is used to determine whether a function is a function or not a function. Horizontal line testing whether the function is one-to-one or not. Okay, so if I go back here, the blue parabola is a function if I use a vertical line test. But if I draw a horizontal line, then that tells me that it is not a one-to-one function. Okay, so what's the big deal here not being a one-to-one function? If it's not a one-to-one function, then you don't have an inverse function. Okay? If you're not one-to-one, then you do not have an inverse function. What you have instead is called the inverse relation. Because remember now, this is not even a function once you drew it out. Okay? So if it's not a one-to-one, then you don't have an inverse function. That means you cannot interchange between your x and y coordinates. Alright, so for example, determine if the following function has an inverse function. So the way to test it out, what I can do is graph it. If I go to square root of x plus 5 in my calculator and graph it, and this will be my picture. So if I use a horizontal line test, a lot of times we gotta be careful. Okay, when these lines get a little bit flatter, that does not mean the y values are the same. Okay, sometimes it is, sometimes it's not. So if I draw a horizontal line through it, it will only cross my function one time. So yes, it's one-to-one. Okay, it is a function. It is also a one-to-one function. So if it's a one-to-one function, then it has what? Its inverse. Okay. So check it out. The y values. Are the y value the same? They are close, but they are still not the same y value. Okay. Cannot have the same y value when we talk about one-to-one function. All right. Absolute value of x, as you remember, is a v. So if I draw a horizontal line through it, it's going to tell me that it is not a one-to-one function. So if it's not a one-to-one function, then it does not have an inverse function. And what it have instead is not an inverse function. What it has instead is called the inverse relation. I can actually have a v open to the right or open to the left, but it's not an inverse function. It's called the inverse relation. Okay, this is playing on these words. All right. So, okay, the idea of inverse function, okay, is the interchange between the x and y coordinates or the variable. So, the way how we denote the inverse function of f is using f of inverse, not f to the -1 power. It's called the f inverse. So if a function is one-to-one, okay, just like my square root function just now, then a formula for its inverse can be found by doing these 4 steps. Okay, got to be one-to-one first, then I can actually follow the 4 steps to find its inverse. Okay, we're going to replace f of x with the letter y. Then we're going to interchange between the x and y variable. That's the key for inverse, is interchange between the x and y. Then we're going to solve for y. Once I get y by itself, I'm going to replace it with f inverse. So, okay, this is a cubic function. So as you can recall, cubic function looks something like this. So if I draw a horizontal line through it, it is a one-to-one. So if it's a one-to-one, then I can find its inverse. Alright, so the first step of the formula, replace q sub x with y equal. Then step number 2, interchange between the x and the y variable. So that means I should have x equals 3y plus 1. whole thing to the third power. Okay, so now step number 3, solve for y. So my y is kind of trapped inside this parenthesis with the third power on the outside. So to get rid of the third power up here, I will take a cube root on both sides, because cube and cube root will always cancel out. So I will have a cube root of x set it equal to just 3y plus 1. Alright, if I move the positive 1 over, that will be cube root of x minus 1 equal to 3y. Alright, divide every term by 3 to get my y equal. So my y is going to equal to cube root of x minus 1. Both terms share the same denominator, 3. Alright, I can write this different. I can write 1/3 cube root of x minus 1/3. Last step, replace y with f inverse. So the inverse function of this original q sub x, you know what, let me use the correct letter here. That would be q of inverse would just be cube root of x minus 1 whole thing over 3. That will be my inverse function. Okay. Alright. Let's check out this one right here. Alright, rational function. Okay, this rational function may look something like this. Okay, so if you draw a horizontal line through it, okay, it is a one-to-one function. But see, this thing, it look flat, but it's actually, the y value is actually real close together. So the y value here is actually not the same. Okay, if you actually grab this function and look up for the look on the table for the y value, every y value is different. So it is a one-to-one function. So that means I can find its inverse. All right, replace k sub x with y equal, so I can interchange between my x and y variable for step number 2. Alright, so now rather than having y equal, I should have x equal -2 over -2y plus 3. Alright, step number 3, solving for y. So right now my y is kind of in the denominator. So what I can do is multiply both terms by my -2y plus 3. Now what's tricky about these problems is the next step. Because now on the left side I have x times -2y plus 3. On the right side, okay, my denominator will cancel out, so only thing I have left with is just my -2. So my variable term is still trapped inside, okay, this parenthesis. So I will do a distribution to bring out my variable term. So that'll be -2xy plus 3x equal to -2. So now to get my variable term by itself, because I'm solving for y, move my 3x over. So that will be -2xy equal to, you know what, I'm not going to do that. I'm going to flip it. I'm going to move my -2xy over, bring my -2 back. So I get 2 positive 2xy equal to 3x plus 2. So now to get y by itself, I will divide every term by 2x. In that case, my y will equal to 3x over x canceled out, so that'll just be 3 over 2. I'm going to put it on the back side, okay? And the positive 2 over 2 canceled out, so that'll be 1 over x. Right, so that would be the simplified. All right, change my y equal back to my case of x inverse. So k inverse of x will be 1 over x plus 3 over 2. Okay. So this problem, when I was solving for y, the y was trapped inside the parenthesis. That's why I have to use a distributive property to bring my variable term out. Okay. Not every problem works the same way. Okay, you really got to look. All right. I'm gonna grab this function. I have no idea what this thing is look like because I got polynomial over polynomial. Make sure it's 1-to-1 before I go through my steps. Parenthesis negative x minus 5. Close it. Divided by x plus 3. I'm gonna graph it. Yep, it's another rational function. So it is a 1-to-1 function. Alright, so step number 1, replace a sub x with y equal. Alright, interchange between the x and y variable. So normally this thing says y equal, now you will say x equal now. This x, these two x's will become y. So that will be negative y minus 5 over y plus 3. So now when it comes to solving for y, I notice I got y in 2 different places. So the first thing should be, okay, this y plus 3, this y can't be in the bottom. Okay, let's move on to the top and we'll see what happens. So multiply both terms by my LCD, y plus 3. We can use a cross product, maybe that will work. This times that, this times that. Okay, either way, doesn't matter what technique you use, it will say x times y plus 3 equal to negative y minus 5. Alright, so now let's take a look. Okay, y here, y there. This y is trapped inside the parentheses, so I'm gonna use distributive property to bring out my y for my left side. So I get xy plus 3x equal to negative y minus 5. Alright, solving for y continuously. Now I got variable term on the left, variable term on the right. So I need to have my variable term on the same side. Because these problems, these y is to the first power, so I am kind of solving linear equation. Okay, those are the steps I'm taking. Move the negative y over, move the positive 3x to the right side. I should have xy still on the left. Negative y come over to the left, become positive. Equal. Negative 5 still negative 5. When positive 3x come over, become negative. Alright, now comes the strange part. The xy plus y, these two terms are not like terms. So how can I have y in 2 different terms make it into just a single y? How can I make these two y into a single y? I cannot do it by combining them because they are not like terms. So what I can do is factor out the y between the two terms. Because since my y repeated between the two terms, that's my greatest common factor. So that'll give me x plus 1. So now I have a single letter y, and to get it by itself, I will divide both sides by my coefficient, which is my x plus 1. Alright, so my y is going to equal to, or my inverse function will equal to negative 5 minus 3x, or you can put the negative 3x in the front, negative 5 on the back, over x plus 1. Okay, alright, that's how we find its inverse function using the formula over here. Alrighty. Alright, Let's do another example here. This problem is it's a bit strange because I give you a function started with, this is a polynomial function, quartic function, x to the 4th power. It's a polynomial function with an exponent that's even. But the constraint is x is greater than or equal to 3. This constraint tells me where should I look at. Because if I will graph this function, parenthesis x minus 3, whole thing to the 4th power, then plus 5. Okay, I have an idea what this thing look like. It look like a U, just like x squared, but it's not quite a parabola. Parabola is only for x squares. All right, it looks something like this. It looks like a U, but it's not quite a U. The constraint says look at this function where x is greater than or equal to 3. So all this negative part right here, I don't need to look. So I'm gonna make this picture look a little bit better. I'm gonna say maybe like a -5. Okay, my y minimum -5. We still see some negative. Okay, so U a little bit more established now. Okay, I call it U. It's not a U. All right, so let me take a picture of this thing. If you draw a horizontal line through this graph, it's not a one-to-one function. However, the constraint says look at this function where x is greater than or equal to 3. If you look at the vertex right now, the vertex is located at 3, 5. Okay, so 1, 2, 3, up 5. So that means the vertex is right here. Look at this function only at x greater than or equal to 3. That's to the right side of the 3. That means everything to the left side of the 3, I'm gonna actually throw it out because the problem never want me to look at that side. All right, when I do it like this, follow the constraint, then this function now becomes one-to-one when I use a horizontal line test. Okay, it's different because the constraint only allow me to look at certain part of this function. So now it becomes a one-to-one. So now I can actually find its inverse function. All right, q sub x, step number 1, make it into y equal. The interchange between the x and y variables, step number 2. So that would be y minus 3 plus 5. Now solving for y. Don't go crazy and start multiplying this whole thing out, okay? That's a lot of work. So what we can do here is little by little trying to isolate, okay, my variable term. Because currently my variable term solving for y is right here. All this is one term, and this term contains my variable. So to isolate this term, I'm going to move my positive 5 over, and that will give me x minus 5 is equal to y minus 3, whole thing to the 4th power. Okay. Now, to get rid of the 4th power, I will take a 4th root, okay, on both sides. But when I take an even roots on both sides, my answer should be what? Positive and negative. So that's y minus 3 is equal to a positive and a negative 4th root of x minus 5. Okay. Now, I cannot use the negative because I have to look at x value where it's bigger than or equal to 3. Okay, so by looking at this function right now, okay, think about this. Inverse function is about interchange between x and y coordinates and variables. So if I were actually interchange between my 3, 5, make it 5, 3. 1, 2, 3, 4, 5, up 3. My graph is actually going to start right here. Okay. And this is a fourth root function. I'm going to show you. Okay. I'm going to do a positive. I'm going to do a positive fourth root. Math number 5. Parenthesis x minus 5. Okay. If I move this negative 3 over, it'll become positive plus 3 in a minute. Then down here, I'm going to do a negative fourth root mass number 5 of x minus 5 plus 3 on the outside. Okay. It goes that way or that way. Okay. Now, x got to be greater than or equal to 3. So check it out. X got to be greater than or equal to 3. So if I will interchange, remember now, this x greater than or equal to 3 was for this function. So for its inverse function, then the constraint will also got to be switched over. Because now my inverse function, use Q. My inverse function is what? Supposed to be positive negative fourth root of x minus 5 plus 3. So if I'm interchanging my x and y variable, then my constraint also got to be switched over. So this is not. So for my inverse function, the constraint is not x greater than or equal to 3. It's y that's going to be greater than or equal to 3. Okay. So look at this. Okay. The first one is the positive one. The second one is a negative one. So when I went to my table, the y value out of the negative one, look at this y value, is actually going what? Downward. It's not going upward. So that's the reason why I'm saying we can only use the positive one, because the positive fourth root will only have y value that keep on going up. Okay. All right. So let me drop. So let me go back here. Delete off the negative one. Let's redraw the picture. Now it's going that way. Sorry. Remember, it's an interchange. Oh Lord. Sorry about that. Sorry about that. So when we interchange between the x and y variable, we also interchange between the x and y constraints. So find the formula for the inverse of the function on a given domain, if possible. So once I find this formula, now this is my inverse function. Now I gotta find the domain of my inverse function. So now, if I interchanged where I began, which was 3, 5, now this point got to say 5, 3. Okay. With the equal to, my domain got to be starting from 5. Keep on going to the right to infinity. Okay, I'm going to add this part, okay? My range for my inverse start at 3, keep on what? Going up to infinity. Alright, compare the domain and range from the inverse to the domain and range of the original function. This point is 3, 5. So that means the domain for my original function starts at 3, keep on going to the right. So the range will start at 5, keep on going up. So now compare between the two domain and range. What do you notice? This was a domain. Now the same 3 to infinity becomes the range because the interchange between the x and the y. Okay, so that means the domain and range will also flip for the inverse function. Okay, alrighty, so that will be all for the inverse function. Thank you for watching.